everyone, I hope you're doing well. So in this video, we're going to discuss the first three problems of Codeforces Round 882, which was written for Division 2. So I was able to solve the first three problems. It is in system testing right now, so it is not showing here. And like today's contest was pretty average for me. I did not read the second problem carefully. That is why I had to make two wrong submissions. And for problem D, I was not able to complete my implementation, although I spent a lot of time on it. But by the end of the contest, I was not able to complete the implementation. Hence, I could only solve three problems. So let us quickly start the problem discussion. We have this first problem. So all of the first three problems were kind of similar, mathematical based, and they were not very difficult, I would say. So this problem, the first problem, says that we have defined the power of a group of villagers like this. So for example, if there are several members in a group, right, their power, the total power will be defined as a of L minus a of L plus 1, a of L plus 1 minus a of L plus 2. So basically the summation of difference of consecutive elements, right. So this will be the total power of one particular group. Now we have like n number of elements and we have been given a value of k. So we have to divide the overall one group into k subgroups such that the final value is minimized, right. The final summation of power is minimized. So this problem was fairly simple and straightforward if you observe it. I'm just going to show you with the help of the first example. So they say that if you see these elements 1, 3, 5 and 2. So if you want to calculate the total power in this particular case, it will be 1 minus 3 absolute value plus absolute value of 3 minus 5 plus absolute value of 5 minus 2. So this will be the total power of this whole group of 4 villagers that has been given to us. Now if we try to find out what is the individual power of each adjacent elements, this will come out to be 2, this will come out to be 5, 2 again, and this will come out to be 3, right. Now you will see that if you want to divide the group into k parts, or if you want to divide this whole group into k different subgroups, then we can safely omit some of these values, right. So how is this possible? For example, if I try to break the group from here into two groups, so this value will be removed of 1 minus 3, right. Similarly, if I try to break the group, let's say from here, you will see that this 3 minus 5 will be removed because this 3 and 5 will not be adjacent now, right. Similarly, if I try to remove or try to form a group from here, then you will see that I can remove this value from the total sum because 5 and 2 will not be adjacent now, right. So each joint is contributing some value, and if I am allowed to make k groups, then I'll be able to break k minus 1 joints, right. So for example, let's say this is the first element a, b, c, d, e, f, g, right. So the difference of these two will be some contributing some value, again these two, again these two, again these two. Similarly, for all the adjacent elements, they will be contributing some value to my answer. So if I am allowed to make k groups, I can break k minus 1 joints among them. So for example, if I want to break into three groups, let's say this time now, so I can make a move here and I can make a move here, right. So this way the whole array or the whole groups will be divided into three different subgroups like this. Now obviously, if I am allowed to remove some of these values, right, and I want to make my sum minimum at the end, so definitely I would want to remove the values which are maximum. So let's say the values in this particular case was 2, 2 and 3, and I can remove k minus 1 of those values. So I will remove the k minus 1s that are the greatest. So in this case, the first greatest value is this, and I'll calculate the sum of the remaining values, right, because this is the value that I have to definitely take. So this was the whole approach. The problem statement was a bit tricky, but the solution was overall very simple, very greedy, and you just have to find what are all those values. You know that you can remove k minus 1 among them, so you will have to pick the k minus 1 greatest values. So once you remove them, you just have to find the sum of the remaining values. So let me show you the code. So this is right now in queue, but I believe like this will pass the test cases as well. So we have two values n and k. and what I do is I create a vector and take input in it, right? Now I create another vector dx, so this is essentially going to store the difference between the adjacent elements, and I initialize my sum with 0. So what I'm doing is for all the adjacent elements starting from 1 till less than n, I'm just calculating the value of these elements, that is v of I minus v of I minus 1. Now I just push back this particular value into my dx vector and I also add it to my sum. Now I sort this particular dx vector and I sort it in reverse order. So this ref sort is not a part of C++. This is my custom function that I have created, and I can also show you it's somewhere here. So right, you see that this is a function that I have created, and this will sort the whole array in reverse order. Now I just take the top k minus 1 among them and subtract it from my total sum. So instead of calculating the sum for the remaining values, I am just calculating the sum for all the values and removing the top k minus 1 among them, and at the end I can just print the sum, right? So you can also go the other way around, where you find the top k minus 1 values and then find the sum for the remaining values. It is obviously going to give the same answer. So let us move on to the next question. So this particular question says that we have been given some values, and this FL2R function denotes the bitwise AND of all the values in the range L to R, right? Now we want that the sum of the strengths of the group is minimized, right? This is our task. Now if there are multiple ways to make the same sum of strengths, I have to maximize the number of groups, right? This is my overall question. So first of all, my primary task is to minimize the sum of strengths of groups, right? So you see that this is accepted while we were talking, and the part that I missed during the contest was we have to minimize the sum of strengths. I was trying to minimize the strengths, but I was not trying to minimize the sum of strength. So at the end I fixed it and it worked. So basically what do we mean by minimizing sum of strengths? So you see that the strength of a group is defined by the bitwise AND of all the elements in it, right? So if I have all the elements and I want to minimize their strength, an obvious approach would be to take all the elements. So if there are multiple elements like this, let's say A, B, C, D and E, right? So what do you think is the minimum strength that is possible? So my task is to find the minimum strength. So if I take the first two elements, let's say like this, and take its bitwise AND, right? Now I take any element in the world, any value I can take, let it be C now. So the overall value of this new expression is always going to be less than, it's always going to be less than or equals to A and B, right? This is the universal truth. If I AND or I take the bitwise AND of any new value with an old value, it is always going to be less than or equals to the previous value. So let me just show you an example for it. So for example, if I have 101, let's say I take some value 010, so it is obviously going to be 000 and it is less than the previous value. But let's say if I take the maximum value that I can, this is this, and still the final result is going to be 101, which is equals to the first value. So this is just a basic property of bitwise AND, that any bit which is not set in the original number can never be set in the final number, and any bit which is already set in the previous number may or may not be set in the final number. So if we follow this constraint, the final result A and B and C is always going to be less than A and B, right? So from this discussion we can conclude that it is always better to take the bitwise AND of all the elements, right, to minimize the strength. So let's say we have two cases. So case 1 is when the final value of bitwise AND, let's say we calculated the bitwise AND of all the values and this value is non-zero, right? So if this value is non-zero, I'm just going to take this whole array. Now case 2 is when I am calculating the same bitwise AND for the whole array and it is a zero value. So if it is a zero value, I can take multiple arrays whose bitwise AND is 0, right? And I can take the sum and the sum is still minimized, right? If I try to take, let's say the final bitwise value was 1, and if I try to take multiple arrays of bitwise value and 1, the total sum will be greater than 1, right? So this is what I was missing. So they are asking us to minimize the strength of the groups, right? and we have to take the maximum number of groups. But if we are taking the multiple groups, then we have to sum up their total strengths, right? So this is what they're asking. So if my total bitwise AND is non-zero value, right? So it is always optimal to take the whole array. But if my total bitwise AND is equals to 0, then I can try to find multiple arrays or sub-arrays which has a value total equals to 0, right? So this way I'll be able to maximize my number of groups. If the value is non-zero, I cannot maximize it, because if I try to maximize the number of groups, then obviously the total new value that I get will be greater than the original value. So basically what I have to do at the end is, the final algorithm is take the bitwise AND of all the values. If it is equals to 0, then I will try to form different groups, right, whose bitwise AND is 0. So how will I actually do it? Let me just show you. So for example, if there are multiple elements A, B, C, D, E and F, and let's say the total bitwise AND is 0, right? So I'll start from here. I'll try to expand my group. As soon as I find that my total bitwise AND value is 0 now, so I'll mark this as one group and start my second group from here, right? So again I'll start from here. Now at the end there might be two cases. I know that A and B and C, that is A and B and C is equals to 0. This is for sure. But D and E and F may or may not be 0, right? So let's say this is equals to 0. In that particular case, the total number of groups possible will be equals to 2. But if it is equals to non-zero value, right? If it is non-zero, that means I will have to include these three elements into ABC, and I cannot consider them as a separate group. So the total number of groups will still be 1, right? So you will have to take care of such details while implementing this problem. Now let me show you the code, what I've done. So you will see that I have created a vector v of size n and taken input in it, and I have calculated the value of need. So this is the bitwise AND value that I need. So basically what I am doing is I am just traversing through the vector v and I am taking the bitwise AND of all the values. So this is some logic when the need value is 0, but at the end you will see I check whether need value is 0 or not. If it is 0, I just print the value of count that I have calculated, otherwise I print 1, right? So how do I calculate this value of count? Let me just show you. I initialize my count with 1 and my index will be 0 and my current value will be v of 0, right? So basically what I do is I just take the bitwise AND of the current index and store it in my current variable. So as soon as this variable becomes equals to my need value, at that particular moment I'll increment my count, because I believe I have found a new group. I'll update my index and I'll update my current value with respect to that index, right? So if index is less than n, I'll update my current value with that particular index. Otherwise I just set it to an infinity value. Now if this is not the case, I'll just simply increment my index. So at the end, as I have told you, either my current will be equals to the value that I need, or it will be not equals to the value I need, right? So the way I have implemented this problem, you will see as soon as I am completing one group, I am incrementing the value of count. So in this case, you will see that as soon as I completed the first group A, B and C, my count value would have become 2. I had initialized it with 1, and as soon as this group is completed, it will become 2. So this is not what I want, because at the end the value of the remaining elements is not equal to 0. So whenever at the end the value of the remaining elements or the bitwise AND is not equal to the value that I need, I'll decrement one value from count. So this is minus count. So at the end again I can check whether need equals to 0 or not. If the bitwise AND equals to 0, then I can just print count, otherwise I print 1. So this would be the solution for the second problem. Now for the third problem. Oh, so it is running on test case 3. Let me just refresh it. Yeah, so it is also accepted, right? So for this particular problem, I would say, like during the contest, an approach came to my mind and I was not sure whether that approach would work or not, because that approach was just based on intuition. But since my contest was already going very bad, I decided just to submit it, and it worked. So at that time I didn't had a proper idea why that worked, but now I have, and I'll try to give you an intuition of why this approach will work. So basically they are saying that we have been given some elements, right? So let's say that there is a value of n and we have been given n elements. So in one operation what I can do is I can choose any of the last m elements. So I can choose one element from the last, two elements from the last, three elements, or four elements from the last, right? Now if I choose, let's say, three elements from the last, I can take their bitwise XOR, right? I can take their XOR, and whatever the new value is, I can append it at the end of the array. So basically, let me just tell you. So let's say I have four values, A1, A2, A3 and A4. So for example, I decided to go with these three values. So what I can do is I can calculate A5 as A2 XOR A3 XOR A4, and I can append A5 to the end of this array, right? Again, I can do the same thing. Let's say I decide to take these two elements now. So I can calculate A6 as A4 XOR A5, and I can append it to the end of the array, right? So this is what the question is saying. I can repeat this particular step any number of times. I can perform this operation any number of times. I just need to find what is the maximum value that I can form using these operations, right? So now in this particular question, you will see that the value of AI is only up to 2 raised to the power 8. So 2 raised to the power 8 is basically 256, and the value of n is 10 raised to the power 5. So now you can try to find the best answer among all the 2 raised to the power 8 values. So what the idea is, if the value of AI is up to 2 raised to the power 8, the best answer or the greatest value that I can form is obviously 2 raised to the power 8. I can never form a value greater than 2 raised to the power 8, right? So this is true with any bitwise operation. If the maximum value is, let's say, 7, no matter what bitwise operation except bitwise left shift and right shift, if I apply, let's say, AND, or even if I apply or even if I apply XOR, no matter what operation I apply, the maximum value that I can form will never be greater than the maximum value among the integers or the values that I am taking. So if the maximum value is 2 raised to the power 8, the maximum value for the answer that I can form is only 2 raised to the power 8. So that means I have 256 possible answers in this particular case, and if the value of n is 10 raised to the power 5, I can easily make a for loop for all these 256 values. So now I just had to figure out some way to check whether the answer exists for a current value of I in O of n time. I can just traverse through all these 256 values, and for each of those values I can traverse the whole array. So the total overall time complexity will be 256 into n, right? So I just had to figure out a way whether I can traverse the whole array, or I can find whether a particular value exists or not in O of n time, right? So how do we do this? So let's say we have some values A5, A4, A3, A2 and A1. Let's say you decide to take the XOR of these four values. So the new value we have to insert at the bottom is A2 XOR A3 XOR A4 XOR A5, right? Now let's say you again take the XOR of these values. So A4 and A5 are going to cancel each other. So the only value that is going to remain is A2 and XOR A3, right? Because these A4 and A5 are going to cancel each other. So what essentially happened is, with the help of this particular operation, you were able to recover A2 and A3, right? So you were able to form some new values out of those existing values. Now let's say you perform a little bit different operation. So let's say this is not here, and you perform an operation like this. So in this case, all of them will be cancelled and only A1 will remain, right? So again you were able to form a new value. But what if I try to make a same operation again? Same operation in the sense, I start from the bottom and take any number of values, right? So let's say this was the operation that I made. So the new value that I obtain is A1 XOR A2 XOR A3, and then A4 and A5 will be cancelled again because of these two values and these two values, right? So you see, I was only able to form A1 A2 A3 among XOR, right? And you will always see third value that I am forming is always possible with the previous two operations. So for example, again I can show you A4 A5. If I take all of those values and take its XOR, I can form A1 A2 A3 A4 A5, and then I can take again the last three values, and I'll be left with A1, A2, A3. So if you try this a couple of times, you will always observe that whatever value I am getting at the third time, it is always possible to form that particular value with only two operations. Right. In the first operation, I'll get the first XOR value, and in the second operation, I'll use this value and some values from the above to find the third value. Right. So even if I apply any operation, I repeat, any operation in this particular array, the answer is not going to change, or any value that I get is always possible within these two operations. So with this particular observation, I established the fact that I can form all of the values possible using only two operations. I don't have a mathematical proof for it yet, but you can find this even during the contest or after the contest. You can figure out this thing with the help of observation, that no matter what operation you make, you can find all the possible values with just two operations. Right. Now let's say you know this fact that you can find any values with two operations. So with this observation, how will you solve this particular problem? Right. This is the next question. So again, let me have some values: A1, A2, A3, A4, A5. Right. So let's say you're traversing this particular array, and you just came till here, right? So let's say your current XOR value is A3 XOR A4 XOR A5, right? And you want to find out whether you can form a total value of I or not, right? So where will I get this I from? As I've already told, our maximum value is 256. So we are going to make a for loop from 0 to 256, and this will be our value of I. So my current value is A3 XOR A4 XOR A5, and I want to find whether I can form the value I or not, right? So how can I form from this particular step? So you will see that if I stop here, then this current value will be placed at the bottom, right? And with this current value, I have to take some elements from here, right? So basically what will happen is the new result, the new value that is being added, and this particular new value that I append at the end is going to be current XOR some value X. So if I already know the value of this new value, then I can find the possible value of X. So this is a very basic XOR property. If I know A XOR B is equals to C, then A XOR C is equals to B, and B XOR C is equals to A, and it can go anywhere around, right? This is true for all XOR values. Now you will see that I know the value of new value, I know the value of current, I can find the value of X, right? So what is this value X, and how will I check whether X is possible or not? So if I have taken these values as current, so X should be somewhere from either A5 or A4 XOR A5 or A3 XOR A4 XOR A5, right? X should be somewhere from here. It cannot go above, because we will consider it in a different case. So let's say it is somewhere from here, right? It is somewhere from the smaller values of A. So what we can do is we can maintain some kind of a visited array, and starting from this bottom position, we will mark each XOR value as visited. So for example, initially A5 will be visited, then A4 XOR A5 will be visited, and then A3 XOR A4 XOR A5 will be visited, right? So this way I'll be able to track this X value is possible or not, right? Because if it is possible, it will be somewhere from here, right? Either it will be this value, or this value. I'll mark all of them as visited, and I can check whether X is visited or not. So you might wonder why I did not go to this particular place, because it will be covered in a different case. It will be covered when, let's say, A4 A5, right? So it will be covered when the current value is this one, and then I can check whether this is visited or not. So you see, it is essentially the same thing. I've taken this part and I've taken the above. So also here also I was trying the same thing, this part and this part. So instead of checking both ways, I can just check if I have current, I can check for all the values smaller than current, right? Or the values before current. So the overall algorithm is to traverse from the bottom and go upwards and mark all of them as visited, and I can try to find the value of X if X is visited or not. If X is already visited for a current value of I, then I is a possible answer, and I can always update my answer as maximum of answer comma I, right? So this was the whole problem. and let me just show you my summation. So you see what I've done here is I've initially taken a vector of size n and taken input in it, and I've initialized my answer with 0. Right, now I make a simple for loop from 0 to 256. So one left shift 8 is 256, and I create a visited vector of size 256. All of them are initialized with 0. I initialize my current value with 0 and I make a reverse for loop. So I take the value of j and XOR it with my current value, and I mark my visited of current as 1. Now I update my answer as answer comma current, because let's say I take some of the values from the bottom and the maximum value is found in only one operation. So that value will be stored in current and I can update it. Now if current XOR I is visited, then I can update my answer as maximum of answer comma I, and at the end I can just return my answer. So you see the code was only this much and it was very simple. The only thing, two things that you have to observe is that the answer is always possible in at most 2 steps, and there are only 256 values, so you can brute force through all of them. So this was all about today's contest. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video was actually helpful for you, and it will be able to reach more number of people like you who want to keep solving new problems. I see a lot of people who watch these videos who are not subscribed yet. In case you are one of them, then definitely consider subscribing. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.